Hello guys and welcome back to another case study. Today we have a steel stair bridge. We're going to run our study as follow. Components interaction bonded and alloy steel material. We will make sure that the subparts are treated as beams. We have a fixed geometry on joints and a force of 3000 newtons on the beams. This picture shows exactly how we're gonna do it. Next, we're going to apply Earth gravity load on the structure on the direction of the red arrow. And finally, we're going to exclude the blue parts from the analysis. And of course, we have these 3 questions to answer later. Now I'm going to open our assembly file. As usual, we go to SolidWorks add-ins, click on SolidWorks Simulation. The Simulation tab will appear, we click on it, and we start a new static study. The first thing we're gonna do is to exclude the blue parts from the analysis. Now we're going to make sure that the subparts are treated as beams. When we click on the parts of the assembly here, we can see that a symbol of a beam shows. It means that this part is treated as a beam. Now we're going to set the assembly material to alloy steel. Next, we have to make sure that the global interaction is set to bonded. Afterwards, we go to fixed geometry, which will be placed on the lower joints. Now we head to external loads to apply our force on the beams. We choose the direction of the force and we set it to 3000 newtons. And finally, we apply the gravity load on the structure. It's time to run our study. And here are the results. The results show that the bridge collapsed, but obviously it's an exaggeration because we're working on a high deformation scale. Now we go to stress and we add a definition. We change the unit to megapascals. We go to chart options, we take the show maximum annotation and we set the format to floating. Here our maximum is 13.373 megapascals. Now we head to displacement. Again we added definition. The unit is already set to millimeters. Chart options, we show the annotation and we change the format to floating. Our maximal displacement is 0.316 millimeters. Now we already answered two questions: the maximum stress, the maximum displacement, and we still have one more, is the stress on a specific node, number 400. We go back to our study, we go to stress, we choose probe at element, and we choose element 400. The stress in element 400 is 1.102 megapascals. That's it for today's video. I hope you enjoyed it. I hope you learned something new. See you on the next one.